apply a small, not small, opposing force. The board will apply the opposing force and the disc will be stopped. That opposing force is called as frictional force. Now look at this picture. You know, in the movie you may have seen this one, right? The Kattappa will moving towards the Bahubali, and definitely the Bahubali will be stopped because the surface, it applies an opposing force. The surface stopped the Kattappa. Then what happened? He will be reaching the Bahubali in a safest manner. Same like that. Here you may have seen these scenarios, right? The ground, the surface will oppose the motion of the player. Okay. So now you may have got the idea what is frictional force. Frictional force means that is the opposing force. Here look at the picture here. He is applying a force, but the frictional force will oppose the motion of the box. So I think you may have got the idea what do you mean by friction. Okay. Now, opposing force is called as friction. Okay, there is no need to read the definition and all. Okay. Now I'm going to explain the types of frictional force. Look at the picture here. If you have a table or if you have a chair, you can try this one, right? Now I'm going to apply 1 Newton to push this box. The frictional force also will be 1 Newton. If I applying 1 Newton, the frictional force also will be 1 Newton. So what will happen? The object will never move. It will be locked in one place. Okay. So now what I'm going to do? Now I'm going to increase the force by 2. Okay. Now if I increase the force up to 2 Newton, then the frictional force also will increase up to 2. Still the object is not moving. Okay. Because it opposing our force, right? It is against our force. Now I have increased the force up to 3 Newton. Still the object is not moving. But do you know the reason? Because the frictional force also 3 Newton. So object is not moving. Now again, I'm going to increase the force 4 Newton. Still the object is not moving because still the surface is giving another 4 Newton. Like that, I'm going to increase the force 5, 6, 7, 8, 9, 10. No, there's no any movement. Still the object is at rest. Still the object is not moving. It is being in the same place. Oh my god. Now what can I do? I want to move that box. So now I'm going to apply 11 Newton. So if I am applying 11 Newton, the frictional force, they cannot give 11 Newton because the maximum frictional force, the maximum force that they can apply, that will be 10 Newton. Beyond that limit, the surface cannot give the force. Surface can only give up to 10. The 10 varankatum they can manage. But after, when I applying 11 Newton, the surface, they cannot apply 11 Newton. They can only apply 10 Newton because the maximum frictional force will be 10. Beyond that limit, the surface will never apply the force. Now, if I have applied 12, then also the object will be at the frictional force will be 10. The object will start to move. Why? 12 Newton. We have won the match. 12 Newton, here 10 Newton. So object will be moving on the direction of that person, right? 13, object will move. 14, object will move. Now, Palahal, you may have got the idea how the frictional force is acting here and how did I apply the force. This is an important part that you want to know, right? So, I'm going to apply the same thing once again. Okay. I hope that you may get the idea, but this is important, but this is a core of this subject. So that's why I'm going to explain once again, right? Okay, try to understand. Now I'm going to push the table. If you have any table or if you have chair nearby you, you can try to push that object, right? So at first itself, you cannot push that object, right? Because when I am applying 1 Newton, the surface also will apply 1 Newton. So we cannot move. Now I'm going to increase the force up to 2. 2 Newton, 2 Newton. No, still the object cannot be moved. Even now I'm applying 2 Newton, the object didn't move. Do you know the reason for that one? Because we have the opposing force 2 Newton. Here opposing force 2 Newton here, so it got balanced. And now I'm going to increase the force 3, 4, 5, 6. So when I am increasing the force, frictional force also got increased. 7, 8, 9, 10, 11. Okay. When I am applying 11 Newton, the surface cannot give 10 Newton. They can only give 10 Newton. No? The maximum frictional force they can give, that was 10 Newton. So beyond that limit, they cannot give the force. The maximum that will be 10. So now what will happen? If I am applying 11 Newton, now the object will start to move. They will move because we are applying 11 here. Frictional force is 10 because we have won the match. So the object will move. 12, 13, 14, okay, blah, blah, blah. The object will start to move. Now, you want to get the idea. I'm going to divide the frictional force into 3 types. You may have got the idea, right? How did I divide the frictional force into 3 types? First one, static frictional force. You know, when I'm applying 3 Newton, 4 Newton, 5 Newton, 6, 7, 8, 9, at that time the object didn't move. Am I right or wrong? When I'm applying 1 Newton, 2 Newton, 3, 4, 5, 6, 7, 8, 9, 10. Up to that time, up to that much, the object didn't move. So the frictional force that applied on the object before the motion, here, 3 here, wait a minute. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these kind of frictional force before the motion, the frictional force applied on the object before the motion, that is called as static frictional force. Frictional force exerted on the body before the motion. And second one, that is limiting frictional force. Okay, now here I'm applying 10 Newton. Yeah, I'm applying 10 Newton. It got balanced, right? So here not it will be start to move. Here they will be giving 10 Newton and also frictional force also will be 10 Newton. So object will start to move, right? Okay, the object is at rest. Okay, fine. But there will be small, slightly just begins to move. Am I right or wrong? When applying 10 Newton. So this kind of frictional force is called as limiting frictional force. That is called as the frictional force that applied on the object when the object just begins to move. Just an time frictional force is called as limiting frictional force. Frictional force that applied on the object when the object just begins to move. Earlier I said that before the motion, now just begins to move. Third one, dynamic frictional force. You know what is dynamic? Okay, here we are applying 11 Newton, applying 12 Newton, 13 Newton. At that time, the object starts to move. So at that time, after the motion, here the object will start to move. So after the motion, we have the frictional force, right? Here 10 Newton. That frictional force is called as dynamic frictional force. Frictional force acting on the body after the body starts to move. That is called as dynamic frictional force. Okay. Now, the second part, that is graph, one of the important part. But in this class, I don't have that much of time to explain the graph. Okay. So just look at this chart. Just look at this chart, right? This is the chart that represent the frictional force and the force that we apply. You may ask, sir, this frictional force graph is not mentioned in the syllabus. So then why are you telling this is that much of important part? You may ask like that, right? In the past paper, we have 2 questions based on this graph. Okay, so I will explain this graph and I will be uploading the video in the YouTube. Right? Don't regarding the frictional force. I have planned to record a proper video for the friction. In a calm mind, because we here in this class, I am being hurried to complete the lesson, right? But I will be uploading another video, a complete calm video by explaining all the part. So at that time, I will explain the graph. Now there is no time to explain the graph. Okay. But keep in your mind the graph is a very important part. Now we're going to discuss what are the factors that affecting the frictional force. Pulahal, I want to ask you one thing, right? In the glass, in this, in the ice and all, we can slide in the ice, right? We can easily slide in the ice. But in the road, we cannot slide in the road easily. I don't know. The tar road we can't slide, but in the ice we can easily slide because Pulahan, look at this picture. In the tar road, the surface is very rough. So what will happen, Pulahan? Two surfaces will be become locked like this. The surface will be become locked because the two surfaces are rough now. So both of the surface will become locked. But when the surfaces are smooth, look at the picture here. If the surfaces are smooth, it will be sliding easily one each other over each other, right? It will be sliding easily. So here, try to get the idea. Here we are sliding easily in the glass because the surface is smooth. But here it is a very difficult task to slide in the tar road because the surface is very rough. Okay, Apula. So did you get that idea? Why we can easily slide on the ice and why here we cannot easily slide on the tar road because the surface is rough. So you may have got the idea. If the surface is rough, what happened, Pulahal? Look at the picture here. Both of the box and the table are locked each other. We have zoomed that area, right? We have zoomed this area. You can look after the picture here. Both of the surface has been locked. So when the surface is rough, two surfaces will become locked each other. But when the surfaces are smooth, there is no lock. So easily we can move. No frictional force. So when the surface is smooth, the frictional force will be low. When the surface is rough, the frictional force will be high. So I hope that you may have got the idea. What is this frictional force and what is this surface and how the nature of the surface will affecting the frictional force. Now the second part, there's a practical, right? Under the second part, there's a practical to prove this one, right? Here I have taken a box here. Okay, I have taken a box here, and here also I have taken the same box, but between the box and the table we have kept a sandpaper. Okay, we have kept a sandpaper. We have attached the sandpaper to the box here. Here we are going to same practical without the sandpaper. Well, I want to ask you one question. You know the sandpaper, right? The surface is very rough here. Am I right or wrong? The surface is very rough. So when I am doing this practical here, what will happen? Here the sandpaper, the rough surface will be here, right? So what will happen below? The table and that box will be attached very tightly because the surface is rough now. You know the sandpaper surface is rough here, right? So when I am attaching the sandpaper under the box, what will happen? The box and the table will be attached tightly because of the rough surface. Surface is rough. Sir, if the surface is smooth, is a frictional force is I know. If the surface is smooth, we can easily slide. That means the frictional force anu sonna mahal opposing force. When the surface is smooth, frictional force will be low and low and low and low. That's why we can easily slide. Because the surface is smooth. So surface smooth. So what happened, Bulahal? Frictional force decreases, so we can easily slide. But in this scenario, the tar road, what happened? Surface become rough, frictional force increased. என்னால move பண்ண முடியல. So here in this box, the same thing happens here. In picture number one, the surface is rough. So surface has been locked. So it will be very difficult to push this box. Am I right or wrong? we want to struggle more and more and more. That means frictional force is high. But here, between the box and the table, there's nothing there, right? There's nothing between the box and the table. Both of them are smooth. So what happened? It will be, we will be easily moving the in case 2, we will easily pull that box. But in case 1, it will be very difficult task to pull that table, pull that box, because the surface, nature of the surface become hard here. So I want to ask you, Plar, did you get that idea? Can you raise your hand, those who didn't get the idea? Can you raise your hand, those who didn't get the idea? It's okay, it's okay, it's okay. You can tell yes or no. You can tell yes or no. Those who didn't get the idea. Okay, one. Only one. Okay. Any others? Those who didn't get the idea? Those who want to explain once again? Okay. Shall I explain? Okay. Wait. Okay. Listen here, Pula. Listen. You know, when the surface is rough, what happened, Bulal? Here, in the case, we'll put case number 1 and case number 2. In case number 1, we have kept the sandpaper. The sandpaper is very, very rough now. So what will happen? Here the rough surface will be here outside. Rough surface will be outside and the smooth one will be inside. We have attached the sandpaper and the box here. So, and Bulal, you can see the screen now. So here what will happen, Pulahal? The rough surface and the table will be locked because the surface is rough. Tar road, the surface is rough. Rough means frictional force will be high. So here in this case number 1, we want to apply, we'll take for example, we want to apply 15 Newton to uh, push that box. Why did we apply 15 Newton? Because the surface has been rough. So what happened? Because of the rough surface, the sandpaper and the table has been locked tightly. But in case 2, there is no sandpaper. Both of the surface will be smooth. So what happened? By using only 10 Newton, we can move the table. In the case number 2, we can easily move the box because there is no any obstacle is not there. Both of the surface are very, very smooth. So what happened? By using 10 Newton, we can easily move the box in case number 2. So now I hope that you may have got the idea in case number 1 and case number 2. In case number 1, the surface nature was rough. So we applied more force. But here case 2, the surface is smooth. Between the table and the box, both of the surface are smooth. So we applied only 10 Newton to push that box. யாரு விலங்கலன்னு சொன்னது யாரு? Hammad Aswad. Did you get the idea, my dear? Oh, shall I explain once again in Tamil? What did you get the idea? Hammad Aswad. Did you get the idea, my dear? Yes or no? Yes, okay, fine. Now Pulahal, we are going to do the question related to the same idea. Right? I think you can see the picture here. Don't take more time. Within 3 minutes, you want to send me the answers through the WhatsApp. Mafia, send me the answers. Sahishan has an please explain third type in frictional force as now only I have joined the class as network issues. Okay, okay. I will explain the third type, don't worry. And
Very
Aki.
three types.
Okay, okay. You are expecting to explain all the three types. Okay, okay. Hey, man. No, no. Sorry. Hey, man, this is the thing, my dear. I will send you the recordings, okay? Don't worry, yeah? I will send you the recordings, okay? Today itself, inshallah, I will send you the recording because you don't have time to explain all the things again. That is the thing, okay, my dear? Sahisan, okay? I will
Okay.
send you.
Okay.
Suddenly I said yes, but it's practically it will be a difficult part to explain. Don't worry, eh? And Akib,
Okay.
very good. Perfect. 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 The unbalanced person. Fine. Fine. Mashallah. Very, very, very good. Eh? Most, என்ன சொல்றது 100 out of 100. Very good. Pakka perfect. Okay. யாரு Akif. And யாரு Shamlan. Where level Shamlan. Yes. Same. Very good, my dear. Yes. Very good. Very good. Very good. Once again. 100% is the accurate answer. Very good, my dear. Yes. Shamlan, very good. And Shara. It's okay. Sarah, it's okay. It's okay. Don't worry. I will explain. Don't worry. Be happy. Don't worry. I will explain. Don't worry. Yeah. Sarah, கவலைப்பட வேண்டாம். Don't worry. Be happy. I will explain. Don't worry. And Jazahilmi. Okay, fine. You have send me the answer up to three. All the three answers are correct. Send me the answer for the remaining questions. Okay, very good, my dear. All the answers are correct. Sarah, ஒன்னும் கவலைப்படுறதுக்கு இல்ல மனசை திடமா வச்சுக்கோங்க. We can do this question. Don't worry. Yeah? And study limiting 14. Yari. I forgot the name. What's the name, my dear? Rahma from Al Hilal. Not Raiha and Rahana, that one. It's Rahma. Rahma from Al Hilal. Sridevi, என்னடா நீ கடைசியா அந்த கவலையில பிள்ளை விட்டுட்டீங்க. All the answers are correct, but the last one you had done the mistake. Okay. No. Sorry. Yes, sir. Yes. The last one is wrong, my dear. Fourth one. Please do the correction for that one. Okay. And but all the other answers are correct. Eh? All the other answers are correct. All the other answers are correct. And Zainab, sir, can you please send the meaning? Great. Sorry. And Hamad Azwar, limiting. Okay. I have sent you only after the second one. Okay, fine. Okay, we'll explain, right? Okay. I think I have corrected all the answers, right? Okay. Now we'll. Okay, another answer is there. How is that? Jazahim. Sagarna, we don't know. You said, okay, don't know. Fine, okay. You can write, don't know. Yes, you will get 100 marks in the exam. Okay. Fine. Now, I am going to explain the question. நீங்க சத்தம் இல்லாம you want to be on your place and you want to listen to me, okay? Don't do any other works. Just listen to me, right? Okay. Ibtihaj. Fine. Very good. Very good. Yes. Accurate answer. Yes. Okay. Now, Pulahal, now listen to me. Don't do anything, right? Don't do anything, right? Here, here there is a object with 4 kilograms. Okay, fine. And they are going to apply the force, and they're going to trying to push that wooden block. Okay. What type of frictional force acting on the block of wood? You know, before. What is the name? Before means static. Static. Static frictional force is the one I already discussed the definition, right? The frictional force that act on the object before the motion. And there are two another one, limiting and dynamic. What do you mean by dynamic? After the motion. What do you mean by limiting? Just begins to move. Okay. And when the force acting on the wooden block was increased, the block of the wood start to move. What is the name used to identify the maximum frictional force that created between the two surfaces? Okay. You may ask like, sir, you didn't said like this any kind of maximum. You may asking like that, right? But in the theory class, we have discussed that one. But today we didn't explain that one. It's okay. Here, Pulahal, I forgot to tell one thing, right? I said that limiting frictional force means frictional force that act on the body just begins to move. You know, just think another thing. The limiting frictional force was the maximum frictional force. Am I right or wrong? I said that 10 Newton. Beyond that 10 Newton, the surface cannot give any other forces. When I giving 1 Newton, they gave 1. 2, they gave 2. When I applying 3 Newton, they also gave 3 Newton. When I applying 4 Newton, they also gave the 4 Newton. I already explained that. But when I am applying 10 Newton, they also gave the 10 Newton. But when I am giving 11 Newton, what happened, Pulahan? They cannot give 11 Newton, right? Because the maximum that was limiting, right? That is the definition. The maximum frictional force that is limiting. But when I explained, I said that what? Frictional force that applied on the object when it's just to move, just begins to move. That was the explanation. That was the definition. And also, we have another definition that is maximum. And also, in the graph, those who have attended the theory class, I think you may have got the idea from the graph. It's okay, fine, it's okay. If you don't know that, it's okay, perfectly fine. The maximum frictional force that is limiting. Right hereafter, if we are hearing any term maximum frictional that you want to know, they are asking the limiting. They are asking the limiting. Here, in this question, they have clearly mentioned that one. Okay, limiting. They are asking only the name, right? So that is limiting frictional force. Maximum frictional force means they are asking the limiting frictional force. And Bulal, here we didn't read this one, right? In that question, they have clearly mentioned when the object starts to move slightly. So when the object starts to move, the Newton balance shows 15 Newton. That means when I am applying the 15 Newton, the object just starts to move. I said that limiting frictional force means frictional force that act on the object when the object just begins to move. So that is 15 Newton. So we can say 15 Newton. Can you raise your hand? Those who didn't get the idea for the second one. Can you raise your hand? Those who didn't get the idea for the second question. Well, I never call you. Neha, okay. Sakibria, Sarah, okay. Okay, Manasala, Rumba Valiki. Okay, fine. Okay. Oh my god. Hey, I'm asking those who didn't get the idea, right? I'm asking those who didn't get the idea. Oh my god. ஆறு பேருக்கு வேலை வேலையா? Fine, okay. Okay. Listen. Neha, Shakib, Sarah, Rukia, Shahishan, and Raiha and Rahna. You didn't get the idea, right? Okay. Fine. Now I can explain once again. Don't worry. Well, in the previous example, I said that when I am applying 10 Newton, the object starts to move. In this example, when I use this picture to explain now. So in this example, I said that when I am applying 10 Newton, the object was moved. But in the question, that is not like that. They have taken another different example. Okay. In the question paper, they have given another example. In this picture, I took when I am applying 10 Newton, object starts to move. But before that turn, before applying, when I 9 Newton, 8 Newton, 7 Newton, the object didn't move. But when I'm applying 10 Newton, the object starts to move. And I said that these 9, 8, 6, they are the static frictional force. And 10, that was the limiting. Why? At that time only the object starts to move, right? So this 10 was the limiting here. But in the question paper, that is not like that. In the question paper, they have clearly mentioned here in this question they have mentioned when I am applying 1 Newton, the object didn't move. 2, the object didn't move. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Still the object is not moving. But when I am applying 15 Newton, then the object starts to move. In this case, but in the example, I got 10. But here in this question, they have clearly mentioned when I am applying 10, 15 Newton, not 10 Newton. So here, the limiting will be 15. But in this example, the limiting was 10. Did you get the idea, Pula? Yeah, in this question, they have mentioned when I am applying 11 Newton, the object didn't move. 12 Newton, object didn't move. 13, no. 14, no. When I am applying 15 Newton, then the object starts to move. So, here the limiting will be 15. Am I right or wrong? Here, limiting will be 15. Did you get that idea? Those who have raise your hand. Did you get this idea? Neha, Shakib, Rukia, Sahisan, and Raiha, Rahana. In the idea, did you get this idea? Here the limiting will be 15. Yes or no in the chat box? Put yes or no in the chat box. You can put chat, yes or no in the chat box. That those who got this idea. Are you sure? Right. Okay. Now, Pulahal. In this question, they are clearly mentioned the limiting will be 15 because when I am applying 15 Newton, then only the object starts to move. No, so limiting was 15. So here they are asking what is the max name given for the maximum frictional force. Hereafter, don't worry, Pulahal. Maximum frictional force means they are asking the limiting frictional force. I think one of you asked the definition for the I want explanation for the B. Okay. Here in this question they have clearly mentioned they are asking the name for the maximum frictional force. What is the name for the maximum frictional force? That is limiting. You may ask, so how can you say that the maximum frictional force is limiting? I don't have time to explain that in today's class, okay? Because this is paper class, no my dear. So just keep it in your mind. Maximum frictional force mean that is limiting. It's okay. No any issues by keeping that one in the mind like this. No any issues, okay? So that will be limiting frictional force. Okay. Now they are asking what is the value of the limiting? You know already we have find that the limiting frictional force that is 15 Newton. Once again, I want to ask, do you have any doubts? If you have any doubts, just raise your hand, no any issues. Raise your hands. Okay, Jazahil. Yes, my dear. Which one? Question number A or B, my dear? Jazahil. Which part that you didn't get the idea? Which question? A part or the B part? Jazahil. A part or the B part? B part, okay. B part, what is the value of the limiting frictional force? You know, limiting means when the object starts to move, there will be a frictional force. That is called as limiting. In this example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So at this time, the object starts to move. So here, the 10 was the limiting. Why? Why the 10 was limiting? Because at this time, when I applying 10 Newton, frictional force was of 10. At this time, the object started to move. நான் 10 கொடுக்கிற நேரம் தான் அது ஸ்டார்ட் ஆகுறதுக்கு மூவ் ஆகிறது ஸ்டார்ட் ஆயிடுச்சு. At this time only the object will starts to move. Same like that. In this question, here in this example, 10 Newton was the limiting. In this question, they have clearly mentioned when I am applying 15 Newton, object begins to move. Here, read the question here. Am I right or wrong? So that's why I said that here the limiting was 15 Newton. But in this example, limiting was 10. And 10 கொடுக்க போகிறதானே மூவ் ஆயிடுச்சு. But in this example, when I am applying 15 Newton, then only they started to move. That's why limiting was 50. Jazahil, did you get the idea, my dear?
Yes, sir.
Okay. All the remaining questions are not related to the frictional force. All the other remaining questions are related to the Newton's law of motion. And I have done more number of questions. Okay. You may remember those parts, right? Now, previous paper class. I have uploaded in the YouTube. You can watch those videos, right? Now, question number 3. They are asking the weight of Sarah. Did you get the idea, my dear? Sarah?
Yes, sir.
Yes or no? I couldn't hear you. Louder.
Yes, sir.
Yeah, sir. Yeah, no, yes, sir. Fine, okay, very good. You know, our parathala solla தெரியுமா? Yes, sir. No, sir. Not no, yeah, illa. Yes or no. Fine. Okay. Question number 3. They are asking the weight. So you know, Pulal, how to calculate the weight. Sarah, அது ஈஸியான கேள்வி தானேமா. It's okay. என்னடா நம்மள குத்தி காட்டுறாரு வடிக்கடி. No, not like that. Okay? Don't think like that, okay? Just be calm, right? You know the equation for the weight. Weight is equal to mass into gravitational acceleration. And here, you know the mass, that is 4 kilograms. And gravitational acceleration, you know the always that will be 10 ms minus 2. So answer will be 40 Newton. Kadum kastamana kanakundelia. It was a very difficult part. Am I right? No. Very, very easy. So weight will be 40 Newton. Very good. Mashallah. Fine. Okay. Now the answer is correct. Yes. That is the answer. Very good. Yes, Sarah. Okay. Now, second question. Fourth one. They are asking the perpendicular reaction. You may ask, so what do you mean by perpendicular reaction? You didn't explain that. Oh, wow, no, just like that. Here, you know, if there is weight, equal and opposite reaction. What is that? Equal. What is it? Equal. What is that? Equal and opposite. That is perpendicular. What did I say, Pulal? Equal and opposite. So, perpendicular reaction mean equal and opposite. So if the weight is 40 Newton, the perpendicular reaction R, that also will be 40 Newton. Why? Equal and opposite. Yaar sonnadu? Newton's third law. Each and every reaction has equal and opposite reaction. So R will be 40 Newton. That is the thing that they are asking. 40 Newton. Sarah, இது கடும் கஷ்டமான கணக்கு. Okay, we want to be very careful in that one, right? Okay. Very easy, right? The first thing that you have made the mistake, Pulal, you have got F right of the question. No, when you are facing the question, you must have the confidence. நான் அடிச்சு தூக்குவேன், என்ன கேள்வி வந்தாலும் நான் சும்மா சமாளிப்பேன். That kind of confidence you want to have. The question is very, very easy. But what happened, Pulal, when I'm reading all these kind of questions? Oh my God, you have been messed up, right? But not like that. You know the answer, Bilal. I definitely know that you know the answer. You know the equation. But what was the mistake that you all have done, Bilal? You have make your mind and the brain as, oh my God, there are more number of questions. No, not like that. First of all, we want to have a calm mind. And we want to read the question once, twice, thrice, and you want to read again and again and again and again until you get the idea. Okay, so now we'll move to the Next part, question number 5. They are applying a force 20 Newton. Here they are applying force of 20 Newton. You know, Pulahal, when they are applying 20 Newton, already the frictional force is there now 15 Newton. Here we are applying 20 Newton. But in opposite direction, we have the 15 Newton of frictional force. So we want to subtract 20 minus 15. 20 minus 15. So what is the first Pulahal? 5 Newton. So the unbalanced force that acting on the object is 5 Newton. But Pulahal, if you are not able to do question number 5, it's okay, fine. Because that question is based on a second term syllabus under the resultant force, that is unit number 11. Sorry, unit number 9. So if you are feeling difficult in that question number 5, perfectly fine, no any issues. If you have done mistake in question number 5, no any mistake from your side. That is totally my mistake, because I didn't explain that term, no, because that is the second term syllabus, no. So don't worry, right? Okay, we'll move to the question number 6. You know, Bilal, equation for the force. Force is equal to mass into gravitational, sorry, not gravitational, just acceleration. And already you have calculated the mass in the question here, not calculated, you have given the mass, that is 4 kilograms. And acceleration here, okay, we don't know the acceleration, right? Okay, we want to find the acceleration, but we know the force, that is 5 Newton. But you may ask, sir, no, we are applying 20 Newton, then how can you put 15? That was explanation, right? Here in this side we have 20 Newton, but in opposite direction we have 15 Newton frictional force, no? So 20 minus 15, that is 5. That's why I have put 5 here. If you have any doubt in that part, don't worry, okay? Because that is out of syllabus, not out of syllabus, a second term syllabus. So if you want to calculate the acceleration, what do you want to do, Pulahal? 5 divided by 4, answer will be 1.25 meter second minus 2. Only this much was the question, right? So, Bilal, can you raise your hand, those who have any doubts? Can you raise your hands? Those who have any doubts? ஏதாச்சும் உங்களுக்கு சந்தேகம் இருந்தால் you can கையை உயர்த்தவும். If you have any doubts, no any doubts from anyone. Okay. Yes, Sara, yes, சொல்லுங்க. In which part do you have the question, my dear? Pardon?
5 and 6.
5 and 6, okay. There's no need to worry about the fifth one, because that is out of syllabus, because here we are applying 20 Newton, frictional force is 15 Newton. The resultant force, that is a separate part in a grade 10 unit number 9. So don't worry about the fifth one. We'll discuss about the sixth one, right? We'll discuss about the sixth one. They are asking the acceleration, and you know the equation, no? Force equal to mass into acceleration. You know the equation. For the force, we want to put 5 Newton. But you may ask, so how can you put 5? Because we are applying 20 Newton here, no? They have clearly mentioned we are applying 20 Newton, but okay, don't worry, because that is our second term syllabus, no? So just leave that one. I will put 5 Newton. You know the mass of the wooden block, that is 4 kilograms, and you don't know the acceleration. So if you want to find the acceleration, what do you want to do, Pulahal? You want to divide the 5 Newton by 4 kilogram. Shara, is it doubt for you? Is this part is not for you, my dear?
Yes, sir.
Right, okay. If you want to find the acceleration, you want to bring the 4 here. You want to divide the 5 by 4. Then you will get the answer 1.25.
No, sir, I understood that part.
The previous one, you're asking for the fifth one, right?
Yeah.
Okay, so shall I do one thing, Bilal? Okay, listen here, right? Listen here. I'm going to do a small thing, right? Sir, okay, wa? Is it okay now? Okay. Just leave that one. Just forget the question number 5. Okay. So is it okay now? Right. Okay. So Pulal, if you have any other doubts, Sarah, is it okay? Okay now. Okay. Any others? Any others? No. Any doubts? Okay. So Pulal, now we have discussed only the 50% of the friction, right? I think in the tute you can see another question. Okay, there's another question here. So when you're coming next class, please do this question. And if you have done already, if you have written the answer already, you can send me the answers through the WhatsApp, right? Okay. Now, Bulahal, we'll conclude the class with the recitations. And if you have any doubts, you can ask me, right? Okay. Once again, can you confirm if you have any doubts? Do you have any doubts? No. Okay. We'll conclude the class. Subhanakallahumma bihamdika ashhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Assalamu alaikum and good night. Have a nice day and Bhavan. We'll meet. Okay, there's a chat box. Sir, jazakallah. Okay, okay. Barakallah. So we'll meet in our next class in next week. Okay. Goodbye.